Hi, myself Puja, Assistant Professor of GKCM of GIS Group, Department of Electronics and Communication Engineering. Here you will find the details of my contact information, and I have developed a Facebook page where regular updates regarding this course are available time to time. Hello everyone. Here in this session, I will be going to explain adaptive delta modulation. So, why adaptive delta modulation is used? So, in previous session, I have already explained delta modulation. So, there are few disadvantages which is there with delta modulation. And there are two issues in delta modulation. One is slope overload distortion and second is granular noise. These two issues that we have already seen in delta modulation. And to resolve these issues, we can go for adaptive delta modulation. So in delta modulation, there are two issues. One is slope overload distortion and another one is granular noise. So these two issues we have already seen in delta modulation, and to resolve those issues, we can go adaptive delta modulation. Okay. So before I explain you adaptive delta modulation and its block diagram of adaptive delta modulation is almost similar to delta modulation. Okay. So now see what is the basic difference which is there in between adaptive delta modulation and delta modulation. So this is the transmitter part of adaptive delta modulation. And in adaptive delta modulation, there is one block that we need to add that is called step size logic control. That is what we add with this delta modulation, and that is resulting into adaptive delta modulation. So this is the one difference of block diagram. In adaptive delta modulation, we need to add the step size logic control block. So this block is added into this adaptive delta modulation transmitter part. Okay, now see, first I will explain what happens in delta modulation and what we resolve that in adaptive delta modulation. Okay, so when you talk about delta modulation, in that how delta modulation graph that is getting initiated. Okay, so first I will explain what happens in delta modulation and then what we resolve that in adaptive delta modulation. So at first we talk about the delta modulation, in that how delta modulation graph that is getting initiated. So in that, if we start from 0, from here, if input signal that is greater than sample signal, then there will be plus delta size. Now see here. Here input signal is less than staircase signal. So there will be minus delta size. Minus delta step size. So see here, this again, if input signal is greater than this, so it will be plus delta step. Again here input signal is less than this, then it is minus delta step. And here input signal is greater than this, then plus delta. And that is how this will generate input signal will greater than this. So it will be plus delta. And that is how this will generate. And this is how delta modulation will generate output. So this is what delta modulated output. So in delta modulated output, when input signal is less than staircase signal, there will be minus delta step size. And when input signal is greater than the staircase signal, then there will be plus delta step size. And this is what the delta modulated output. Okay. So this is DM signal and this is original signal. So if you see the difference between original signal and DM signal, there is a big difference in between these two. So this is what quantization error, which is happening because of delta modulated signal. So the big difference is the quantization error, which is happening because of delta modulated signal. And this is what we want to resolve by using adaptive delta modulation. Okay. I have already discussed in previous session, like see, there is a quantization error, and that quantization error that is happening as per two issues. One is granular noise and second is slope over distortion. So granular noise that is happening when step size is too large. Okay. And overload distortion that is happening when step size is too small. So in granular noise, we should decrease step size, and in slope over distortion, we should increase step size. So this is what we want to do in adaptive delta modulation. Because we know that two issues, there one is granular noise and another one is the slope over distortion. In granular noise, we have seen that that is happening when step size is too large, and slope overload distortion that is happening when step size is delta is too small. So in granular noise, we should decrease the step size, and in slope over distortion, we should increase the step size. So this is what we want to do in adaptive delta modulation. Okay. So for that step size logic control could be explained a mathematical expression. Like see, at sampling time n, the step size delta n is given by delta n equal to mod of delta n minus 1 into En plus delta 0 into E of n minus 1. So this is what basic mathematical expression which we need to use have calculation of step size. Okay. So this is the mathematical expression for step size control. And so here En is the current error and En minus 1 is the previous error. Okay. Now see, I will explain how to have a calculation of step size step by step. So let's see. We will be initially this calculation at n equal to 0. Okay. So this is the basic formula. Delta n equal to mod of delta n minus 1 into En plus delta 0 into En minus 1. So this is the mathematical expression of step size control, for controlling the step size basically. So now, let us have calculation for n equal to 0. Now see, if n equal to 0 and if you started from here, then input signal is greater than staircase signal. So if n equal to 0 and if you started from here, then input signal is greater than staircase signal. So error is positive. So here we should say error E0, that is positive. If error is positive, then send +1, and if error is negative, then send -1. And in this case, E0, that is positive, because input signal is greater than the staircase signal. So just applying that basic formula, you will be having first delta, that is what, delta 0, and that is already we have considered delta 0. So you just take it delta 0 equal to delta 0. So it is what, plus delta 0. So from there will be step size is what, delta 0, like this. Okay. So it is what, plus delta 0, and the step size what, delta 0 is like this. Okay. Now let us have the second case for n equal to 1. Okay. So now n equal to 1, and now see this input signal actually less than staircase signal. Now see, this input signal actually less than staircase signal. So input signal is less than staircase signal, then error is what? Error is negative. So U1 is -1. So in that case, delta 1, that will be mod of delta n minus 1, means delta of 1 minus 1 is delta 0, and En, that is actually -1. So mod of delta 0 into -1 plus delta 0 into En minus 1, that is +1. This is the previous error, which is +1. If you calculate this, you will be finding this is minus delta 0 plus delta 0. So the result will be 0. It means the step size will 0 over here. Okay, so the step size will 0 over here, and this will remain same. Okay. Now for again n equal to 2. Now n equal to 2. So one can see here this signal is less than staircase signal. So now input signal is less than the staircase signal. It means error is negative. So E2 that is negative. It means E2 is -1. Now see delta 2. So delta 2 is the mod of delta 1 into current error, which is now -1, plus delta 0 into previous error which is also -1. So delta 1 that is 0. Okay. So it will be minus delta 0, because the result will be minus delta 0 for n equal to 2. So here for n equal to 2, step size is minus delta 0. So we should make it like this. Okay. Now it will reach up to like this. Okay. Now for next, n equal to 3, where original signal is greater than the staircase signal. So error is positive. So E3 is positive. So consider plus 1. So if we calculate delta 3, that is mod of delta n minus 1 means delta 2 previous value into current error is plus 1 plus delta 0 into previous error, that is minus 1. So delta 2 that is minus delta 0, but mod of that will result into delta 0. So it will be delta 0 minus delta 0. So the value will be 0. Okay. So this is not having any step size because the result is 0. So again this is reaching over here. Okay. So for n equal to 4, where you see input signal is less than staircase signal. So for E4, error is positive. So send plus 1 in error. So delta 4 equal to, that will be mod of delta 3 into, this error is positive, so it is plus 1 plus delta 0 into previous error, that is also plus 1. So this is 0 plus delta 0. So it will be delta 0. Because the value of delta 3 is 0. 0 into plus 1 is 0 plus delta 0 into 1. So it will be delta 0. So here it will increase like this. So for n equal to 4, the graph will increase like this. Okay. Now for n equal to 5. Here message signal is greater than the staircase signal. So error E5 is positive. So it means +1. So delta 5, that is mod of delta 4 into current error, that is +1, plus delta 0 into previous error, which is also +1. So the delta 4 value is delta 0 into 1 delta 0 plus delta 0 into 1 delta 0. So delta 0 plus delta 0, it will be 2 delta 0. So here for next step, you will be finding this will be having 2 delta 0 step, because now the result is 2 delta 0. So this will be having 2 delta 0 step. So compared to delta modulation, now step size is increasing. Okay, so one can see it over here. Now it is reaching over here. So compared to this delta modulation, here the step size is increasing in adaptive delta modulation. So one can see it over here. Now it is reaching over here. So for n equal to 6. So now n equal to 6. So original signal is greater than the staircase signal. So error will be positive. So for n equal to 6, E6 is positive. It means you have to send +1. So when you calculate delta 6, that is actually mod of delta 5 into current error, which is +1, plus delta 0 into previous error, which is +1. So that is 2 delta 0, because the delta 5 value is 2 delta 0 into 1 2 delta 0 plus 1 into delta 0 delta 0. So the result will be 3 into delta 0. So it means now you will be finding step size over here, and that is 3 delta. So it will reach up to this. So now it is 3 delta. So it goes to 3 step. It will reach up to this. Okay. Now again it will compare it with original signal. So original signal is compared with this staircase signal, and again original signal is greater than staircase signal. It means for n equal to 7, error is positive, because original signal is greater than the staircase signal, so error is positive. So E7 is positive, so it will be +1. So when you calculate step size delta 7, that will be mod of delta 6 into current error, that is +1, plus delta 0 into previous error, that is +1. So mod of delta, the value of mod of delta 6 is 3 delta 0, and plus delta 0 into 1 is delta 0. So the result will be 4 delta 0. So here when you send signal, there will be step size, which is 4 delta 0, and it will reach up to this, because for n equal to 7, it will be 4 delta 0, so it will reach the fourth step up to this, and this is what for 4 delta 0 step size. Okay. Now for n equal to 8. For n equal to 8, error will be E8. Now see, here original signal is less than staircase. So it means error is negative. So here error is negative. So you send -1. So delta 8, that is mod of delta 7 into current error, that is -1, plus delta 0 into previous error, that is +1. So the value of delta 7 is 3 delta 0. Okay, sorry, the value of delta 7 is 4 delta 0. So 4 delta 0 into -1, that is -4 delta 0, plus delta 0 into +1, that is delta 1. So -4 delta 0 plus delta 1, it will be, -4 delta 0 plus delta 0, it will be -3 delta 0. Okay, because the value of delta 7 is 4 delta 0. So 4 delta 0 into -1, that is -4 delta 0, plus delta 0 into +1, that is plus delta 0. So -4 delta 0 plus delta 0, that will be -3 delta 0. It means from here there will -3 delta 0. So it will reach up to this. And this is how it will happen. So this is for n equal to 8. Okay. And again it will compare with to its original signal. So original signal is greater than this. So it means error is positive. Okay. So for n equal to 9, E9, that is positive. That is positive error. So send +1. So delta 9, that is mod of delta 8 into current error, that is +1, plus delta 0 into previous error, that is -1. So it will be, the value of delta 8 is -3 delta 0, and because of this mod, it will be 3 delta 0 minus delta 0 equal to 2 delta 0. So this plus 2 delta 0 means it will reach up to this. Okay. Now it is plus 2 delta 0. So it will reach up to this. Now again, you will be comparing over here. So this is last calculation I will be showing over here. So for n equal to 10, the original signal is less than the staircase signal. So the error is negative. So E0, that is negative, means you will have to send -1. So delta 0 equal to mod of delta 9 into current error, that is -1, plus delta 0 into previous error, that is +1. So that is delta 9 value is 2 delta 0. 2 delta 0 into -1, so that is -2 delta 0 plus delta 0 into 1, that is delta 0. So -2 delta 0 plus delta 0. So the result will be minus delta 0. Okay. Now we will be finding this is what having minus delta size. like this. Okay, so now the result will be minus delta 0. So now this is what having minus delta size like this. So this is how we keep on repeating in delta modulation. If you observe this much amount of gap that we have felt actually, so we can reduce granular noise. This is what we are reducing, granular noise, and here we are reducing slope overload distortion. So these two noise, that is what decreasing here using adaptive delta modulation. And when you see this basic formula, this formula is step size control, and that is having understanding based on actually error signal as well as previous delta size. So one should use step size logic control of this previous delta size as well as error signal, so that it can be proper logic control over here. So now let's see the receiver part of adaptive delta modulation. So this is the receiver circuit of adaptive delta modulation, and in the receiver of adaptive delta modulator shown in this figure, so there are two portions. The first portion produces the step size from each incoming bit. Exactly the same process is followed as that in transmitter, and the previous input and present input decides the step size. It is then applied to an accumulator which builds up staircase waveform, and the low pass filter then smoothens out the staircase waveform to reconstruct the original signal. So this is what actually done in receiver part. Okay. Now let's see the advantages of adaptive delta modulation. So adaptive delta modulation has certain advantages over delta modulation. Number 1, the signal to noise ratio becomes better than ordinary delta modulation because of the reduction in slope overload distortion and granular noise. Okay, so because of the reduction in slope overload distortion and granular noise, and so the signal to noise ratio becomes better than ordinary delta modulation. Number 2, the dynamic range of ADM is wider than simple DM. So the dynamic range of adaptive delta modulation is wider than simple delta modulation because of the variable step size. And number 3, utilization of bandwidth is better than delta modulation. So this is the overall adaptive delta modulation, and I hope that you have understood this session, and thank you so much for watching this video.